Hello guys, welcome to session 9. In last session we discussed about the embryo, especially we discussed about dicot embryo and we discussed about endosperm. So this is the last session in this topic. Okay. So today we will going to focusing on the structure of monocotyledon embryo. So monocotyledon, as we know that it is a consist of only one cotyledon, especially in case of grass family cotyledon is called scutellum. Yes, in case of monocot, especially in case of grass family, the cotyledons we are calling as a scutellum, and it is situated towards the one side, especially on the lateral side of the embryonal axis. Okay, so we are discussing about structure of monocot embryo. So monocot embryo possess only one cotyledon, especially in case of grass, the cotyledons we are calling as a scutellum, and it is situated in the towards one side or lateral side of the embryonal axis. Okay. Yes, the at the lower end of it, at its lower end, at its lower end, embryonal axis has, yes, embryonal axis has radicle and root cap. It consists of radicle and root cap, and this root cap is enclosed by a undifferentiated sheath called coleorhiza. Yes, so embryonal axis has radicle and root cap, and its root cap is covered by undifferentiated sheath called coleorhiza. Now, what is the functions of coleorhiza? Means it helps in the protection, or it is acting as a covering layer, right? The portion of embryonal axis is the below portion is we are calling as a radicle, and it is having the root cap. The portion is a portion of the embryonal axis above the level of attachment of scutellum is called epicotyl, and this epicotyl has a shoot apex. It has a shoot apex, okay, and it having the primordial leaf, or it is a leaf is a primordia and enclosed in a hollow folia structure. So it is covered by a leaf-like structure, and that is what we are calling as a coleoptile. Now, what is the functions of coleoptile? Means it is also act as a protective for the these shoots and leaves. In this slide, we're going to be discussing about the seed, right? So seed is nothing but it is a final product of sexual reproduction in the endospermic plant, right? So seed is nothing but it is a fertilized ovule, right? So seeds are formed inside the fruits, okay? So seeds are formed inside the fruit. A typical seed consists of parts like seed coat, cotyledon, and embryonal axis. Okay, a typical seed consists of different parts. So what are the parts? One is seed coat, cotyledon, and embryonal axis. Okay. Now the cotyledons of embryo are simple. So these cotyledons are simple structure. Generally they are thick and they are swollen due to storage of food. Especially these things we have, find in case of legume plants. Okay. Yes, we also mentioned the seed coat. So seed coat is nothing but it is a nothing but integuments. Okay, so we already discussed in the ovules that ovules are covered by the two integuments. One is inner integuments and outer integuments. So these three integuments only they are become the seed coat. So outer one is we are calling as a testa, and inner one is we are calling as a. Okay. We can observe this structure seed in these diagrams. Okay, so here you can observe this diagram. In last slide we discussed about seeds. Okay, so in this slide we're going to discussing about endospermic seeds and non-endospermic seeds, albuminous or non-albuminous seeds, based on the presence of the utilization of endosperm during the development of embryo. So based on that, we can classify the seeds into albuminous seeds and non-albuminous seeds, or endospermic or non-endospermic seeds. Okay. Now first we'll focus on the non-albuminous. Okay. So seeds have no residual endosperm, means during the development of embryo there is a complete utilization or the complete consume of the endosperm. Those seeds were calling as a non-endospermic or non-albuminous seeds. For example, pea plant, groundnuts, etc. Okay. Next one is albuminous. So here, so during the development of embryo, there is no completely utilization of endosperms. Those seeds were calling as a albuminous seeds. For example, wheat, maize, barley, castor, sunflower, etc. Okay, so we can easily understand. So if it is utilized completely, those were calling as a non-endospermic. If it is a remain, it is not completely utilized, some part will be remain, those we are calling as a albuminous seeds or endospermic seeds, right? So next we'll focus on the perisperm. Perisperms occasionally in some seeds such as black pepper and beet. Okay, in case of pepper and beet, remnants of nucellus. Okay, remnants of nucellus are persistent. It will be remain. Okay, we know that nucellus. Okay, nucellus, it is a parenchymatous cells. Yes, it is found at the time of, yes, at the time of development of the embryo sac. It will found surrounding of the embryo sac. That nucellus, it will be remain, and this nucellus we are calling as a perisperm. So this residual persistent nucellus is called perisperm. Okay. Yes, we know that as seeds mature, yes, as seeds mature, it will losing its all most of the water content. As seeds mature, it will be losing the most of the water content. There will be remain only 10 to 15%. Okay, so we know that it is a because of losing of the water, it's become dry and it's become hard. Okay, so here generally what happens here, the metabolically active of the embryo slow down. Here the metabolic activity will get slowed down when the favorable condition comes. So it will, yes, it will go for the germination, and the inactivity or resting period we are calling as a dormancy. Resting state we are calling as dormancy. When it is germinate, when it is get favorable condition, that time it's going to be germinates. Okay, so as ovules mature, as ovules matures into what? So ovules are, yes, they are, after fertilization ovules are become seeds, and ovaries are develops into a fruit. Okay. In this slide, we want to focusing on the fruit. Okay, now what is a fruit means? Fruit means nothing but it is a ripened ovary or fertilized ovary is called fruit. Okay, ripened ovary or fertilized ovary is called fruit. The wall of the ovary, the wall of the ovary, it is developed into as a wall of the fruit is called pericarp. So this pericarp we can go into again differentiate into three layers: outermost, innermost, and middle one. So outermost layer, that is we are calling as a epicarp, middle one is we are calling as a mesocarp, and inner one is we are calling as a endocarp. Okay, so fruits may be fleshy or it may be dry. So fleshy fruits like guava, orange, mango, etc. Dry fruits like groundnut, mustard, etc. Right? So many fruits are evolved mechanism for dispersal of seeds. Yes. So many fruits, they are even involved in the mechanism for dispersal. Dispersal means the seeds will be break out of the fruit. That is what we are calling as a dispersal. Okay. So we know that after the fertilization, what will happen to other parts? Yes, the other parts will be get degenerate and it is a fall off. Okay. So next we discuss about true fruits and false fruit. Okay, I'll focus on true fruits. So most of the fruits, yes, the fruits which develop from the ovary, those fruits we are calling as a true fruits. Okay, those fruits we are calling as true fruits. The fruits which develop from the ovary, those fruits we are calling as a true fruits. Now what is a false fruit means? These are the fruits which not develop from the ovary. It may develop from other part of the, yes, other part of the flower. Those we are calling as a false fruit. True means it should be must and should be developed from ovary. Now what is the meaning of false? Apart from the ovary, the fruit will develop, those fruits we are calling as a false fruit. For example, apple, strawberry, cashew nut, etc. They are developed from the thalamus. Okay, those fruits we are calling as false fruit. Okay, next we know that almost most of the species fruits are result of what? They are result of the fertilization. Okay, but few species are there. Yes, the few species are there in which the fruit will be developed without fertilization. Here, so without fertilization, the fruit will be developed, and those such fruits we are calling as a parthenocarpic fruits. Means there is no syngamy. So without fertilization, there is a formation of fruits we are calling as a parthenocarpic fruits. For example, banana. Okay. So partheno can be induced. Partheno can be means without fertilization fruit can be formed, and that can be induced through the application of growth hormone. If you apply the growth hormones, okay, so it's become parthenocarpic fruit. Okay, and such fruits are seedless. Those fruits they don't have a seeds because they don't. Why they don't have seeds? Because they are not fertilized. If they are fertilized, it means they are having the seeds. Okay. Okay, in this slide, we can observe here. It is a fruits. Okay. So we can observe parts like endocarp, mesocarp, and thalamus. Okay. So first one it is showing the it is a false type of fruit. So second one you can observe that it is a true fruit. Okay. Yes, we'll come to a last slide. In last slide, we are going to discussing the concept like polyembryony. So now what is the meaning of polyembryony means? It is a condition in which two or more embryos develop from a single fertilized eggs. Okay, so poly means many, yes, embryo means the structure formed after the zygote, that is what we are calling as polyembryony. So polyembryony means it is a condition in which two or more embryos develops from a single fertilized eggs. Okay, so we can find a polyembryony in case of citrus, apuntia, and mango plants. Okay, so last part of this chapter, so that is a homework. We're given some questions, important questions on this topic. Okay, so first one is define perisperm with an example. Second question, what is a polyembryony? Give example. Third question, distinguish between true fruits and false fruit with examples. Next question, what are parthenocarpic fruits? Give examples. Next question, write diagrammatic representation of embryogenesis in a dicot. What is endosperm? Distinguish free nuclear cellular endosperm with an example for each. Next question, define seed. Distinguish between the albuminous and non-albuminous seeds with suitable examples. Next question, sketch and label the structure of monocot seed. Next question, what is the apomixis? Give example and mention its significance. Next question, with a neat label diagram, describe the structure of dicot embryo. Last one is a describe structure of monocontrol embryo with neat label